Hello, in this video I would like to talk about a different concept because the continuation of the previous videos. And in this video I would like to answer this question that whether mathematical development paths are if the development mathematical path is unique. If the if I mean in the previous video I said question and answer develop in a loop and they evolve alongside each other, question and answer. And as the question becomes clear, the answer becomes clear as well. Uh, so the question I would like to answer in this question is whether this development path is unique or not. And there's a very use, there's a very good, basically example in this situation. I use it a lot, and that is perception in humans. Consider this as an event, something, and different people perceive the same thing in different ways because they view the same incident from different angles, from different perspectives. So they perceive the same incident in different ways. So this incident is a fact, but this fact is perceived in numerous different ways. So the question is that whether the perception of this incident is unique. I mean, if only one of these perceptions is correct and all other perceptions are wrong. So there's only one angle, one perspective that provides the correct perception. So this is the question I would like to answer in this video. And more specifically, I would like to talk about mathematical structures. So the question is whether mathematical structures can be developed in different ways or the development path is unique. So let me raise this. I want to talk about an example that I talked about in the previous video as well, and that is projective geometry. I said that in projective geometry, the structure is not complete. This is z equals 0, and this is the observer. This is z equal 1. This is z equal 1. Um, this is a perpendicular line. So this is 0 of z equal 1, but it doesn't matter. Okay, and this is some slope that intersects with z equal 1 at points A. So this structure is incomplete. Firstly, because this line is half line, I want a complete line. I want to turn this half line into a line. So let me extend this line. So now this line here is a line. It's not a half line anymore. It's a line. And it intersects with z equal minus 1. So now I decide, this is the perpendicular line. Let me draw it more clearly. So I decide that z equal minus 1 is in the opposite direction compared to z equal 1. And the reason for that is that now this slope intersects with z equal minus 1 in some other point called B. So now I have a line. So now each slope in projective geometry is a line. And I have a structure that is divided into two sections. One section is this z equal minus z equal 1. The other section is z equal minus 1. And as I explained in the previous video, this produces a loop. Now I can make a few choices here. I can make some adjustments here. I mean, making some decisions here to make this construction bit more complex. Uh, so firstly, let me discuss something else. So forget this thing for a while. I will come back to it later. Uh, this is z equal 1, the positive portion of z equal 1. So as you notice, this z equal 1 is now a half line. It only contains the positive portion. It doesn't include the negative portion here. So this is the negative section of z equal 1. This is the negative section of it, but I omitted here. I omitted the negative portion in this structure. So how can I add it in this structure? How can I add the negative portion of z equal 1? So I want to have both sections. I want to have the positive portion of z equal 1, and I want to have the negative portion of z equal 1. I don't want this z equal 1 to be a half line. As I said, this slope is now a line. Uh, I, I extended this to into a line, but now z equal 1 and z equal minus 1 are half line, and that is not satisfactory. I want z equal 1, uh, and I want to have both z equal 1, the positive portion of z equal 1 and the negative portion of z equal 1. So how can I add the negative portion of z equal 1 in this structure? Note that I cannot write draw it as a line. So the first thing comes to one's mind is that, okay, just extend this z equal 1 in the negative portion, and that is z, basically z equal 1, the negative portion of z equal 1. But this doesn't work. Why? Because if I extend z equals 0, z equals 0 now consists of two sections. One section, one section corresponds with this positive portion of z equal 1, and the other portion now corresponds with z equal minus 1. So if I extend z equal 1 in this way, then the negative portion of z equal 1 corresponds with this section, which is inside, which is not satisfactory, because this portion of z equal 0 now corresponds to two totally different entities. One is z, the negative portion of z equal 1, and one is the uh, this portion of z equal minus 1. But these two things are, these two entities are two very different things. I don't want to mix them up together at this point. So uh, basically, I cannot do that. Okay, I cannot extend z equal 1 as a line. I cannot say, okay, this is z equal 1. This is the positive portion of z equal 1, and this is the negative portion of z equal 1. I cannot do that. I cannot, this doesn't work. This doesn't work. So now what can I do? One solution is to say, okay, if this is the positive portion of z equal 1, this is the positive portion of z equal 1, the negative portion of z equal 1 can be perpendicular to that. But this perpendicularity is different from perpendicularity in the conventional mathematics. I mean, this is a 1D world. This space is 1D. Let me write here. This is a 1D space. 1D space. So perpendicularity in 1D space makes no sense. But since perpendicularity in 1D space makes no sense, I I can define perpendicularity in this case. So I say, okay, z, the positive portion of z equal 1 is perpendicular to the negative portion of z equal 1. And this perpendicularity is, of course, very different from the conventional perpendicularity we are familiar with in conventional mathematics in geometry. Uh, these are two totally different things, so don't confuse them together. So if the positive section is perpendicular to the negative portion, then I have an entirely new space here. I can call it zero zone. Zero zone. Because this zone doesn't exist if the positive and negative portions construct a straight line. If they construct a straight line, then there's no zero zone here. But if they are perpendicular, I have a totally new space here. I can do whatever I like with that. I mean, this space, zero zone, is now available to me. I can develop mathematics. I can construct some mathematics in this space, and I can attach this totally new space to projective geometry. So, okay, let me raise it. Let me raise it real quick. I can scroll, but I can also raise. So, okay. Okay. So now what the structure now is a bit more complex. I have some z equal 0 here, and this z equal 0 here corresponds the positive the positive portion of so this z equals 0 produces the positive portion of z equal 1. So this is z equal 1. I draw it here. I draw it down here because you you will notice. Okay, I have okay. No problem. Uh, this z equal 1. This z equal 1. I draw it here. You will understand why shortly. I should finish this video very quickly. Uh, okay, this is z equal 1. Uh, and now this is the positive portion of z equal minus 1. Z equal minus 1. Z equal minus 1. Okay. Now uh, I draw this is the positive portion. I draw the negative portion of z equal 1 here. This is the negative portion. This is the zero zone I talked about. Then this is z equal 0 in the negative direction. So this portion of z equals 0 produces the negative portion of z equal 1. And these two portion basically intersect with each other at some point. So I have a totally new entity here. I have totally new section here. This is the zero zone. This is a totally new structure entity here. And in the previous um, in the conventional in the conventional projective geometry, there's no zone between. I mean, there's this point and this point. These 2 points are the same in the conventional projective geometry. But in this version of projective geometry, these two are two totally different points, and they intersect at a new point here. I call it O. I call it O, and okay, let me raise it. Well, raise this z equal 0. This is not good. Okay, and then z equal 0 starts. Okay, I called. Okay, I shouldn't have raised it. It was good. This is z equal minus 1. This is z equal minus 1, corresponding to the positive portion of z equal 1. So I draw a positive here. So this is the positive portion of z equal minus 1. And similarly, I have I have a negative portion of z equal minus 1. And this portion of z equal minus 1 corresponds to this portion of z equal 1. And this portion of z equal minus 1 corresponds with the positive portion of z equal 1. Z equal 1. So the point I'm trying to make is that this construction is not unique. I mean, I made a few choices and constructed totally new spaces. For example, a zero zone here, totally new entity here. And again, there's a zone here between the zero of the positive portion of z equal 0 and the negative portion of the z equal 0. There's a totally new space, if you like, space here. So in this structure, there are totally different objects, different entities, different spaces that I can work with, I can construct, and I can keep developing these sections and add them to the projective geometry. So the point I'm trying to make is that uh, with a few choices, I could extend projective geometry into a totally new structure. And this totally new structure is not unique. This is not unique. And this is the point of this video. This is not unique. Uh, so basically, uh, uh, I produced a loop for projective geometry, but this loop is not unique. I made some choices to construct this loop, but I could do uh, other choices. I could make other choices and construct a different loop. So thank you for watching. Thank you very much.